Welcome back. In this video, we're going to go over section 6.2, which is about simplifying square roots. In the last section, the square roots we simplified, basically the radicands were just perfect squares. In this section, they're not, but they have perfect square factors. So let's take a look. The first thing to know is the criterion to tell you whether or not if a square root is in need of simplification or not. The square root of a is considered simplified if a doesn't have any perfect square factors. So, for example, the square root of 50 is not simplified because 50 is divisible by 25, which is a perfect square. On the other hand, the square root of 30, that's simplified because there's no perfect square factors of 30. It's just 6 times 5, or 2 times 3 times 5, and none of those are perfect squares. So that's how you decide. The tool that you use to simplify radicals is the product property of square roots, and it reads like this. If a and b are non-negative real numbers, then the square root of a times b is the same as the square root of a times the square root of b. So let's try. So we want to simplify first the square root of 48. So what you'll want to do is try to think about how you can factor 48 so that there are perfect square factors. So at first glance, you might think, well, I know that 48 is 6 times 8. And while you could do that, 8 has 4 as a perfect square factor. You typically want to try to do this as efficiently as possible. So the cleanest way to do it would be to factor this as 16 times 3. 48 is the same as 16 times 3. So then we'd apply this property and write this as the square root of 16 times the square root of 3. Then the square root of 16, we can evaluate that, and that's 4. So we would end up with just 4 square roots of 3. If we had persisted and used 6 times 8 instead, then we could write this as the square root of 6 times the square root of 8, using our product property. The square root of 6 doesn't simplify, so we would be stuck with it at first. 8 would be 4 times 2, and then we'd have the square root of 6, the square root of 4, square root of 2. The square root of 2, the square root of 4 we can evaluate, and it is equal to 2. And that gets us part of the way there, but the thing is that the square root of 6 has 2 as a factor, and there's also a 2 underneath this radical. So if we write that as 3 times 2 underneath that root sign, we'll see that we could have, and still could if I really wanted to, recombine those radicals so that I can get those 2 square roots of 2 together. But instead, it's easiest, as I'd said, and as you can see, fewer steps, much fewer steps, to just try to get the perfect square factor taken care of right away in the first place. All right, so here let's try the square root of 45. This one's going to be easier because there's really only one way to do it. 45 is 9 times 5. We'll rewrite that as the square root of 9 times the square root of 5. And then the square root of 9 is 3. So we'll just have 3 square roots of 5, and that's it. Okay, so let's try 288 next. 288 is 2 times 144. And then, so we'll write that as the square root of 144 times the square root of 2. And the square root of 144 is 12. So we'll just end up with 12 square roots of 2. Okay. Next up, we see some that have some variables in them, and that's okay. For the square root of b to the 5th power, I want to write that as perfect squares, and also the part that is not. So b to the 5th power, that's 5 factors of b, right? Don't worry, I won't write this out every time. That's 5 factors of b. So we'd have b squared, and another b. So, or in short, that's b to the 4th times b. We'll write that as b to the 4th times b. This gives us the square root of b to the 4th, square root of b. The square root of b to the 4th is a b squared. We'll have b squared times the square root of b. Okay. That may have been a little tricky. Fortunately, we will try that again right now. Okay, let's try 16x to the 7th. So I want to separate this into perfect square factors and everything else, all the stuff that isn't. X to the 7th is x to the 6th times an x, and x to the 6th is x cubed squared, right? So we'll write that as x cubed squared, and then we'll have a kind of stray x left over. Okay, we'll write that as the square root of 16x cubed squared, square root x. That will be 4x cubed, square root x. Okay, here's a couple more to try. Here's one for you to try. Take a minute, pause the video, and then try this yourself, and then restart the video and see how you've done. All right, so let's see how this will go. So 32y to the 5th power, we're going to separate this into perfect squares and not. So 32 is 16 times 2, and 16 is 4 squared, and then I'll have an extra factor of 2. Y to the 5th power is y to the 4th power times another y. So I'm separating the radicand into perfect square factors and then factors that are not perfect squares. So then we'll write that as the square root of 16y to the 4th, square root of 2y. Okay, the square root of 16y to the 4th will be 2y. And then we'll have a square root of 2y. And that's it. All right, we have one more to try. This one is 98, the square root of 98a to the 7th, b to the 5th. So once again, we'll separate the perfect square factors out. 98 is 49 times 2. A to the 7th power will be a to the 6th power times an a. B to the 5th power will be b to the 4th power times a b. Okay, so we've separated the perfect squares from the things that are not. And then the square root of 49a6b4 will be 7a cubed b squared. So we've just taken the square root of the number part, and then for the exponents on the variables, we're just dividing them by 2. So we'll end up with 7a cubed b squared, square root of 2ab. Okay, here are a couple more for us to try. We want to simplify 3 plus the square root of 32. So if you were just starting out, you may want to simplify the square root of 32 part kind of separately first. So let's do that. 32 is 16 times 2. So that's the square root of 16 times the square root of 2, or 4 square roots of 2. So 3 plus the square root of 32 is the same as 3 plus 4 square roots of 2. Okay, and that is the end of that. Okay, next up we have 10 minus the square root of 75 over 5. So I wouldn't try to do anything like cancel the 10 and the 5 or anything like that. We'll worry about any kind of simplification in a minute. 75, that is going to be 25 times 3. And so we'll have the square root of 25 times the square root of 3. The square root of 25 is 5, so we'll end up with 5 square roots of 3. That's just for the square root part. Putting it back into our expression here, we'll have 10 minus 5 root 3. That's over 5. And then we should simplify that further. So I could tell there's a common factor of 5 in the numerator and denominator. We'll go ahead and factor out that 5. So that will leave 5, 2 minus root 3 over 5. Those two factors of 5 will divide out, leaving us 2 minus the square root of 3. Okay, and that's as simple as it's going to get. All right, that takes us through the first part of it where we've done all the multiplication property part. In the next video, we'll continue with this simplification by working on the division property. In the meantime, let me know if you have any questions and have a great day.